where we are in a position to receive or to take up a lot of activities on the small accommodation, and now there is the base foundation for the system of expansion. I think I have completely
अरे ఇలా పట్టుకోరా రే ఇలా పట్టుకో బ్యాక్ ఇలా పట్టుకో
always
స్టేజ్
to engineering college. While compared with other colleges, I think I thank principal and
జరగరా
for agreeing me to participate in this. But whereas
అరే ఇట్లా పెట్టరా
just now which we have a confirmation
అరే
from the principal.
అన్నా ఇందులో ఓరియంటేషన్ పోర్ట్రేట్ పెట్టినావా ల్యాండ్స్కేప్ ఓరియంటేషన్ ల్యాండ్స్కేప్ పెడితే మొత్తం ఇట్లా వంకర వస్తుంది పోర్ట్రేట్ పెట్టు
రీల్ లెక్క వస్తుంది
But whereas
ఇందులో కాదు ఇది లైవ్ సెట్టింగ్స్ ఉంటాయి కదా అన్న వేరేలా పెట్టారు నాకు ఈవెంట్ ఉన్నప్పుడు చూసుకోవచ్చు ఎట్లా అన్న ఓకేనా సెటా ఒకసారి ట్రై చేయాలన్న ఇందులో ఎట్లా వస్తాను లైన్గా అక్కడ మూమెంట్ అవ్వు నార్మల్ లైవ్ లెక్క అక్కడికి వెళ్ళేసిన తర్వాత ఒకేసారి సెటప్
so that's why I think in fact the Professor Naveen is also initiated to have a MOU with
1967, which all started the lunar exploration race. And the Americans, they really got perturbed by that success of erstwhile Soviets. And that time, the American president declared that the Russians step ahead than Americans. The Apollo program in 1969, the first lunar human landings have happened. And all of you must know that, or you all may be knowing the first man who landed onto the moon surface. And subsequently, the Apollo program continued till 71. And in total, many people may not know that around 12 astronauts have walked onto the moon surface in different Apollo programs. So those was the early days of the lunar exploration. In a country like India, if you have to invest in some of this space exploration program, you need to also develop or galvanize a community, the space exploration or the lunar exploration community, which is also very small. In fact, not many people in India are working on these topics. So to have a mission, which basically going to have some kind of a spending, you have to have a purpose and you have to have a national consensus that the outcome of this exploration mission will definitely provide scientific benefits to the country, and of course in long run there will be major benefits from such program. And that's how a lot of conferences happened. The Chandrayaan-1 was conceived, and basically Chandrayaan-1 mission was a truly international mission. It was an orbiter mission. It has hosted payloads or instruments from 11 nations, 6 nations, 11 instruments were there. We had instruments from Americans, we have instruments from European countries, different European countries have contributed, and of course the instruments from our own country, which was basically contributed by ISRO. Now, the Chandrayaan-1 launch has happened in 2008 or so, and subsequent to that, the orbiter started orbiting the moon surface, and large amount of remote sensing data was acquired by this number of payloads, which were observing moon in different part of electromagnetic spectrum, starting from X-rays to visible to infrared, and then of course in the microwave region. And each of this this instrument had a definite objective to achieve. When it comes to the imaging itself of the moon surface, if you have to think of making habitats on the moon, you need to know what kind of landforms are there, what type of surface topography is there. Many of you must have seen moon from a distance sitting over here. That's around roughly 384,000 kilometers. Moon looks a pretty surface, very smooth surface. And in poetic sense, our Vice Chancellor sir was there in the morning. He is a man of sociology. We were having discussions about science and society. But moon has always been linked with the beauty. All beautiful people have been described by poets, and they have been compared with moon. Words like Chandramukhi and other things, these comparisons are very common in poetry. But when you go closer to the moon and you start imaging moon surface, you will find that moon surface is not as smooth as we think, sitting over here on Earth. It is impacted by large amount of on Chandrayaan-1. So we learned about great details about the topographic variability of the moon surface and the impact craters which are present on the moon surface. This camera, not only it was doing imaging at high resolution, but it also had capacity to do imaging from 3 different angles at same surface. So using concept of photogrammetry, we could also derive the third dimension of the moon surface, that means the topographic variability. So we have now a very high resolution topographic image of moon surface, and we could estimate the depth of the craters, we could estimate the heights of the mountains, and then other landforms on the moon surface owing to the data which we received from Chandrayaan-1 mission. Then there were spectrometers. Spectrometers are instruments which basically make measurements in different wavelength regions of the reflected energy of the sun. So using one such spectrometer which was put by NASA, a JPL instrument called Moon Meteorology Mapper, by making measurements at around 2.8 micrometer wavelength, we could also establish the presence of water molecules onto the moon surface. So what happens whenever there are water molecules present on any body, even on Earth, and if you make measurement in those regions, they will absorb the sunlight much more compared to the area where water molecules are not present. So using this basic physics principle, this spectrometer found, at many locations of the moon, water molecules were present, a million, thousands parts per million, very small quantity, trace quantity. They were observed especially in the polar regions of the moon surface. And then by using another instrument which works in the microwave region of electromagnetic spectrum, we could also assess solid ice deposits in regions that are known as permanently shadowed region in the North Pole and the South Pole of the moon. And these regions are called PSR regions, and using SAR data or the microwave data where you don't need sunlight, because this area they never receive sunlight, they are very cold, the temperature is around 50 K or so, they are known as cold traps. The presence of solid ice was established using Chandrayaan-1 data. Chandrayaan also, we had another probe called Moon Impact Probe, which basically descended onto the moon surface, and there was a mass spectrometer on that, and that also provided evidences of near surface water molecules. So in that context, large amount of scientific information was gathered about the lunar environment, lunar radiation, as well as the lunar surface topography, its composition, its minerals, its rock types, and of course presence of water and ice onto the moon surface. That was the contribution of Chandrayaan-1. More than thousands of papers, scientific papers came out of that, and I was also privileged to be one of the person who has done extensive research work using Chandrayaan-1 spectrometers data sets. Subsequent to Chandrayaan-1, naturally we had to think about the second mission, because when Chandrayaan approvals were being sought at that time, our Prime Minister was Atal Bihari Vajpayee ji, and when ISRO chair and other senior people approached him for the lunar mission approval, it was basically Chandrayaan. Then he added a word, in front of that, and said it should be Chandrayaan-1. It should not be a one-off mission. That was the vision, from the. That means that there should be follow-on, missions, so that we can have more detailed understanding about the lunar processes and lunar surface. And then, of course, potential lunar habitation in future. That's how the Chandrayaan-1 came, and then we started working for Chandrayaan-2. The next logical, outcome of orbiter missions are the landing missions. Once you have orbited around, a lot of remote sensing. Other thing is that you go and land and then do in situ measurements and do and a rover, supposed to have a lander, and supposed to have lander can carry a rover, because lander will be fixed, it will be lying at one location, But if you have a rover, it can basically go around it. It can do a lot of other scientific measurements. It can make measurements about the lunar geology, lunar mineralogy, and presence of other elements onto the moon surface. So that was the scientific idea, and around that scientific idea, engineering, was conceived. Lander. The lander was supposed to come from Russians. Years of Russian that basically got backed off, and then the lander also was subsequently it was decided it should get developed within ISRO along with our own rover, and that's what it took large amount of time. From 2008, the Chandrayaan-2 mission finally, it took off in 2019 with this configuration, and we could successfully build our own indigenous lander with propulsion systems and then a landing body onto the lander, because when you have to land onto any body, especially the moon, you cannot have, because there is no atmosphere, so you don't have parachute systems, flexibility, so you have to descend, or you have to make this craft to land at a designated place. And it was also decided to land onto a region which is supposed to program, which has already been announced, that it is going to be a sample return program. That means we will have a robotic mission, it will have a lander, and lander will have a capability to basically collect lunar rocks from one or maybe multiple locations, and then these rocks will be brought back to the Earth's surface for doing large amount of geochemical sampling and analysis of the lunar samples at multiple laboratories in India, maybe in next 4 to 5 years itself. So you can imagine the kind of challenges which were there in the landing mission, but when you are going to have a robotic mission, the challenges are going to be of extreme nature in terms of large amount of work to be done in autonomous robotic system design, scooping the sample itself. Then you have to have a new design of the craft itself, that the sample will be put into a container, and then it has to go back to an orbiting module, and from that it has to return and then come back and pass through the Earth's atmosphere and successfully land onto the moon surface. All these things are full of challenges, and probably you can think that what way you will be able to contribute to that. But of course, this is a kind of sample return mission which has already been demonstrated by many others, like Chinese have already done it, Russians have already done it. The next logical, step is habitation of the moon, making permanent bases on the moon, and that will require another kind of challenge. That means if you have to have long-term human presence on the moon surface, you have to think of long-term sustainability on the moon. You have to have structures which has to be built by the lunar regolith. You have to extract elements and minerals onto the moon surface itself. You have to have extraction of water from this water ice as well as water molecules, so that the drinking water will be available, and this ice resources basically has to be exploited for generating oxygen, so that the people or the astronauts which are living onto the moon, they can breathe, otherwise there is no air onto the moon surface. So these are another kind of challenges which basically should kindle thoughts of metallurgists, civil engineers, electronics people, and another biggest challenge on the moon is the radiation challenge. So you have to basically safeguard yourself from harmful radiation so that you can have long-term sustainability. So all these things will happen, and many of you will see that these things will happen in some of our own lifetimes, and therefore definitely they are going to happen in the lifetimes of these youngsters which are sitting on the back benches. So with these thought process, I thought I will just tell you that the autonomous robotics, 3D printing technologies, advanced propulsion systems, and space debris mitigation are going to be the 3-4 critical engineering challenges in realizing habitation on the moon in long term. So some of you, I think, having multidisciplinary programs in these engineering institutions, probably some of these ideas will be ideas for future, and you can think of creating good amount of capacity as well as human talent in these upcoming areas, and definitely ISRO will try to help you in whatever way we can help. because the India's lunar program is going to be a long-term program. That's what we can tell you with confidence. So with these words, thank you very much once again for inviting me over here, and I look forward for very fruitful interactions and deliberations during these 2 days, and the outcome of this very unique conference definitely will help India's lunar exploration program in long term. Thanks a lot and wish you all the best, and very happy New Year to each one of you. Thank you.
Thank you so much. Thank you so much, sir, for that amazingly informative speech. It was truly a wonderful game to know your perspective on lunar surface and understanding it better. As ISRCE 2023 takes its further steps, I invite to the stage the Vice Principal of our University College of Engineering, Professor P. Chandrasekhar sir, to offer his words on this resounding event.
Dignitaries on the dais and off the dais. Good morning to one and all. It is my privilege to propose formal vote of thanks on behalf of University College of Engineering and Alumni Association on the occasion of inaugural session of Second International Symposium on Recent Challenges in Engineering. On behalf of Principal, teaching, non-teaching faculty, my beloved students and Alumni Association, we profusely thank Dr. Prakash Chauhanji, Director, National Remote Sensing Center, ISRO Hyderabad, Chief Guest of today's function, for gracing the function and inspiring all our young brains, and your compressed and impressive journey of Chandrayaan you explored, and the roadmap of ISRO and the future challenges, what our students or faculty can also think in the direction. Thank you for your talk, sir. We sincerely thank Dr. V. Seshagiri Garu, distinguished scientist, Satish Dhawan Space Center, ISRO, and Sri P. Ram Reddy Garu, guest of honor of today's function, for their presence. We extend our thanks Dr. Vijay Kumar, President Alumni Association, Krishna Director, MS Venkatramaya, General Secretary, heads of the departments, faculty members of all the departments and non-teaching staff, and distinguished alumni of our college for their presence today. We thank print and electronic media for their coverage. We thank all the members of organizing committee members and my colleagues who have been involved in the successful event of this. Last but not least, we thank our Honorable Vice Chancellor, Professor D. Ravindra Garu, a guiding force to our institute and support and for his presence today in spite of his busy schedule. Lastly, a big round of applause to all our student volunteers who are tireless efforts in making this symposium. Right from the inception, they were contributing in all phases. So that's what Dr. Vijay mentioned. Right, in all phases they are involved. It is, in fact, an indigenous symposium we are conducting with the support of our students, and I congratulate all the students for their contribution. So let us all join for national anthem, and then we have a day of tea, and again come back here for the plenary talk.
Himalaya, Yamuna, Ganga, Uttara Coming up, we have a plenary talk by Dr. V. Sheshagiri Rao sir. So I request everyone to be please seated.
Please join your hands together and welcome him.
Learned faculty and my dear children, all students, please be seated. We are having the plenary talk, keynote address be given right away because I think we ran out of time in the beginning when we started half an hour late. Apologies for the same. Okay, we'll close the session and go for lunch. Thank you. No, I have to.
To all of you once again. I am going to talk about the pros and cons of colonizing the home. If you want to do that, what are the technical and engineering challenges? You all know that after the success of Chandrayaan, there is a lot of interest in the community, especially in the young students and entrepreneurs and the industry. When such a community is there across the globe, what are they doing?
Are they have any plans to colonize moon? If so, what are they? What the governments are doing, various governments across the globe? Let us have a kind of a audio-visual talk here. You are able to see the slides? You got it ready? Okay. Let me tell you, as a part of the initial information before talking about colonizing the moon, in a given solar system, whether it is ours or anywhere in the galaxy, how do you find out a habitable world? They have some definitions to say that a particular region is habitable. Otherwise, we'll change it to other one. Need that. Okay. Slides may not come properly. when you want supplies to the astronauts there, or somebody wants to replace the current astronaut there, the crew module will again get docked. It is called International Space Station, which is orbiting for so many years now, and let's say people are living there. I want to ask the students here, is there atmosphere there? No atmosphere. And are the astronauts staying there? Yes. The maximum duration the astronauts have stayed is for more than 1.5 years. So that means when there is no atmosphere, when you create an atmosphere at zero gravity, and the crew member who stayed more than 1.5 years is staying there, means if similar arrangement is made on moon, is it possible to stay? How many of you agree? Why not? When people are staying in International Space Station, why not on moon when similar arrangements are made? So that is why the first arrangements for any person to stay at moon will be something like this. There will be ISS kind of a station revolving around the moon. One module will start from Earth, gets docked to the similar station. There is another module which gets undocked, take the astronaut or the human to the moon. So that means you need a gateway there. Here we call it as an ISS, and there we can call it as a gateway. Is anybody building gateway? The answer is yes. Maybe in another 5 years we will see a gateway around the moon. This is the one. Actually, the moment all these things happen, where do you get the abundance of water? You get water stored in large volumes in South Pole or North Pole. Even though the temperatures range from minus 170 degrees to minus 200 degrees to plus 173 degrees. That means daytime the temperature is 173 degrees. Night time nearly minus 200, 193. So that means such an extreme temperature. What will happen to the water? Water will get evaporated. If that is the case, how do you get solid ice or ice water? It's not possible. So the scientists feel there are large craters in South Pole permanently in the shadowed region. In the daytime also they are in the shadowed region. The reason is the elevation of the sun over moon is not more than 20 degrees. You will not get overhead sun there. That is the reason in the cold zones of the craters, lot of water must have got locked there. If you are able to extract that, convert that into liquid water and store, then it is possible. That is why everybody would like to see the poles, the future point of view. This is where our Chandrayaan 3 has landed. I don't require to mention because Chauhan Saab has mentioned many of these things. This is the type of soil there. And this is one experiment that was conducted. See, you are talking about daytime. The daytime surface temperature, let us say, minus 100 degrees, plus 100 degrees or 60 degrees. What will happen if I drill the surface to a distance of few millimeters? Forget about, let us say, meters of drilling because we have to take a heavy equipment. If I drill it for few centimeters, what will happen? And that is the experiment done by Chandrayaan 3. You can see here, within 80 millimeters of depth, the temperature measured was minus 10 degrees. That means what? On the top of the surface, you have a highest temperature. The moment you just go below 80 millimeters, you have minus 10. That means what? Is the surface conductive? Not at all. Can you generate electricity with thermocouple? Maybe. On the surface you have 100, and just below 8 centimeters you have minus 10. Thermocouples may work, and this may be an experiment where using thermocouples you can generate electricity there. This is one experiment where it has given a lot of data about the conductivity. And this is the experiment where the abundance of elements were found out. You can see the aluminium, you can see the sulfur, and many other things, calcium, ferrous, chromium, titanium, and many things, the presence were found. This is the experiment done for the type of particles there, energy particles, and some kind of, let us say, tremors, lunar surface tremors. So this is the order of the tremor, which is much less than the Earth. So these tremors may occur, let us say, about 500 in a week, whereas in Earth, you get 5,000 a week, and they are all minor. So this is another experiment done there. And that is why, if at all you want to make it habitable and extract all these elements and get a benefit for the society, many countries are in the race. These are all the countries, you know them very well. Ours is the fourth country, where Chandrayaan has landed in the South Pole, and you have also seen in the newspapers that Japanese Slim is going to land on 20th of January 2024. It has already entered the moon's orbit, and it is going to land there. Are there private parties? Yes. There are so many private parties. You have iSpace, you have Draper, you have Astrobiotic, and many things. Many companies have announced that they are going to reach moon with their own investment. If that is the case, there is a governmental organization which is going for moon. There are private organizations which are going for moon. Let us see what they are going to do. This is the one announced by the NASA. You all know that the Apollos are the ones which took the human to the lunar surface. But here afterwards, such attempts are called Artemis. Artemis is the god of, let us say, moon, goddess of moon. And the Artemis 1 series is going to take humans to the lunar surface for colonization. So the first one is Artemis 1. They have already completed in November 22. This is only taking the lunar human carrying module to the lunar orbit and brought back and landed. It took around 32 days, it has landed. That means Artemis 1 is successful. Artemis 2 is going to take human and again circle it to the moon and come back. Artemis 3 is going to take a gateway, part of a gateway to the moon where it can circle there. And Artemis 4, you are going to dock with the gateway and take a human to the moon. So that is the order of the Artemis series, and in the big way it is going on. This is Artemis 1. I will not talk more details about this. This was completed, and where the capsule which is supposed to carry humans has taken a circle around the moon and come back and landed. That means the crew module have been tested in all respects, and landing on the moon and let us say take off on the earth has been successfully done. This is Artemis 2. The module will carry a human and again bring back. It will not land. And you can see the type of subsystems where on the right side there are at least 17 subsystems that are going to get qualified for moon service. What are those 17 subsystems? Who is making it and what do they do? And this is the one, Artemis 3. You are going to see a moon in the middle and you have a long elliptical orbit there. In the long elliptical orbit, you can see a white gateway type small icon. That is nothing but the gateway which is circling the moon in the long elliptical orbit. It is something around 8,000 by 80,000 kilometers. In this gateway, a person who starts at Earth will get launched, get docked to the gateway, and from gateway, another module will get, let us say, started and take the person to the moon. That is the idea. This is Artemis 3. This will go on like this, and this activity will continue for up to Artemis 5. That means the full gateway will be ready. How that gateway will look like, you can see this. You are able to see Orion in the slide. That Orion is the module which connects Earth and the gateway to and fro. And you are able to see the insider content, a descent element, a transfer element. So that is the module which takes, let us say, the humans once again, if they transit into this module, this gateway to the moon. So that means straight we are not going to the moon. First get docked to the gateway, spend a day there, and enter into the another module, and let us say that module will take it to the moon. So this is the layout of the gateway. These are the various subsystems. You have a power system, you have a module for carrying to the Earth, and you have a robotic arm, you have an airlock system, you have an atmospheric system, you have a e-spirit. E-spirit is nothing but the fueling module. The fuel tank is carried and docked to the gateway. So there is no need, let us say, the traveling modules up to the gateway to the moon have to store a lot of fuel. Otherwise, where do I get, let us say, the incremental velocity purpose of fuel? That fuel is taken in the form of a tank, and that tank is also docked to the gateway. That means you have a fuel tank, you have modules for moon and Earth, and you have a chambers for stay, and people can stay here for years together. That is the intention of the gateway, to make it ready in the beginning. And you can see here how the gateway is built. This is an animation which show you how the subsystems have been being made and brought into a gateway type organization. This is the Orion. The name given is Orion to shuttle between Earth and gateway. And this is the logistic module. And the participating countries are also shown here. This is the robotic arm, and followed by you get the human landing system that takes you to the moon. This is the arrangement actually the Artemis is making to make a travel to the lunar surface. That means you can imagine the entire thing. People want to make it operational in the first 4 years starting from, let us say, 2024. See, for example, you have a gateway, you have an Earth, you have a moon. How do you communicate? The communications. And because, in vacuum, first of all, I want to make give an information to you. How many of you feel that when we are talking like this, the next person is likely to listen when we are on the human surface? You cannot. There is no medium to carry your voice. The mechanical waves cannot travel on moon surface. That means if you take 4 or 5 people and if you make them stand a meter apart, what they are talking an individual cannot, other person cannot listen. That means you have to talk through the RF wave. That is another limitation. If there is no atmosphere, whereas Mars has got an atmosphere. When there is no atmosphere, when you want to talk and let us say make your voice audible to the next person who is sitting by the side, it's not possible. So that means you have to test the other communication. That is why, as a part of the Artemis, they have released and launched a capsule satellite for all communication purpose, and that was also successful. And based on the capstan satellite given information, they have made out the communication technologies. This is what they are going to do. By the time Artemis 4 comes, your gateway will be ready, your progress is shown here. So at the end you can see right side there is a gateway. And what are the technologies that are going to come up to make this as a reality? These are the technologies. You need Orient to be tested for humans return, deep space logistics, a flagship for gateway, a cargo return, Artemis surface science, that means lunar surface science, and the power systems, the research bench, many things. And parallelly people are doing biological testing. These are various things that are coming up by the time a human is supposed to be taken onto the lunar surface. This is one. What is the reality of moon colonization? Definitely is a major change for life, for people on Earth. As I said in the first slide, the International Space Station point of view, if you are acclimatized to stay in the International Space Station, and International Space Station, in one day, how many sunsets and how many sunrises an astronauts will see? If I say that one orbit for International Space Station is 1.5 hours, you have 16 orbits in 24 hours. That means how many sunrises, how many sunsets a person in International Space Station will see? 16. You will see 16 sunrises, 16 sunsets in 24 hours when you are in a International Space Station. Whereas, if you are on the moon, 14 days daytime, 14 earth days is daytime, 14 earth days is night time. If you say that one daytime, one night time is called a day, when you take earth as the reference, such a thing is 28 days on moon surface. Can a human biological cycle adapt to that? It may not. It won't. And what they do is, they take you into a capsule. In 24-hour cycle, day and night they create. That's how they do it. So that means the reality is, if you adopt to all these things, I said the mechanical waves will not travel. Even if you take a big bulldozer instrument and start doing work, nothing will be heard. The machine will work, but there will be a lot of dust. What will happen to the dust when there is no atmosphere? When a bulldozer creates a dust, how much time it will take to settle? It will not settle. It will take few more days to settle. That is what has happened in Chandrayaan 3 landing. There is a lot of dust cloud because in the absence of atmosphere it won't settle. That means wherever the construction work is going on moon, you have to be aware. And it is not visible also, it is a dust cloud. What instrument is doing, you may not be able to see there. So this is the type of, let us say, the surface morphology you are going to see there. Let us look at compare Earth and Moon. The radius point of view, you all know that it is 1/6 of Earth. The mass you know, mass ratios you know, the acceleration to gravity is also 1/6. And a person who weighs 60 kg will weigh only 10 kg there. And all your movements, you have to adapt to the 1/6 of the gravity. Not only this, all your equipment you have to make to this gravity and many other things. And the much more there. You are always exposed to the solar radiation, which consists of alpha rays, beta rays and gamma rays. Alpha rays, you can protect by a paper. Gamma rays, you can protect by a plastic. Whereas the gamma rays, beta rays you can protect by a plastic. Gamma rays, you can only protect by a construction, a wall. That is why the UV radiation point of view, people have to be inside, they cannot be outside. That means what? All the equipment when you take there, when you assemble there, when you want to work, you have to work remotely. Where do you stay there? In your bunker? Perhaps. See the lunar atmosphere. A thin atmosphere consists of very, very small traces of argon, sodium, potassium, and you know the cosmic rays are the hazardous, and they are of the order of 1 to 10 GeV for nucleon, the solar flares, and many other things. This is called space weathering. The advantage today is the model is available. The entire thing you can make a mathematical model because the atmosphere has been studied, the constituents have been studied, and I can make a model. If you are able to create a lunar surface of 1/6 gravity on Earth, and this particular simulation you can make instruments ready for lunar surface. This is another thing. They recall it, that means the dust on the surface, most of the thing, that is 97.9% is calcium oxide and aluminum oxide and silicon oxide. That means there is a plenty of extractable oxygen. So much. Can I take a small dust particle and extract oxygen? Yes, it is possible. That's what the instruments are being made. And similarly, there is a helium that is available for capture. Helium-3, if you are able to capture, and that captured volume is, for example, if it is 1 centimeter cube, if you are able to capture 1 centimeter cube of helium-3 and bring it to Hyderabad, through nuclear fusion, you can create nuclear energy for 10 years uninterrupted. If that is the element available there, imagine that other countries mine it and bring it here. 1 centimeter helium-3 cost, I am not able to tell how much it is. Definitely, it is beyond doubt. When such a thing is being mined, we should not be second to none. That is why the technology point of view, the surface information point of view, we have to be ready. And similarly, the albedo in the total solar system, which is the brightest star, symbol of love, Venus. The Venus reflectivity for sunlight is 0.76. Next, Earth, that reflectivity is 0.3. And the moon's reflectivity is 0.12. That is albedo, reflective coefficients. So that means you have a reflection thing that can bring some of the technologies suitable to that. See, as I said in my initial talk, DARPA is an agency. It's called Defense Advanced Research Project Agency in US. They have identified 14 companies to develop lunar economy. They have already started, and they have a project called Novel Orbital and Moon Manufacturing Materials and Mass Efficient Design. That is NOM 4D. And it has got a logic. Logic is nothing but Lunar Operating Guidelines for Infrastructure Consortia. That means lunar operating guidelines are available, and you have a new method for manufacturing materials and mass efficient designs, and you have a goal that 2040 you need a small colony at moon surface. Imagine that 14 companies have come forward. So that means it is done by NASA. This particular thing is in place straight away. Let us see what they are doing. Which are these 14? They are actually the Blue Origin, Cislunar Industries, and I read only some of them. Northam Gunman, Red White, SpaceX, Firefly Corporation, and many other things. They have got, the private parties put together has got a metal framework. It is called metal framework, and they want to make everything ready by 2035. Metal framework is nothing but material extraction, treatment, assembly, and logistics. All of them are under a consortium. If a particular person take up, let us say, power generation out of the 14, unless otherwise it is an independent new design, the other person will not take it, because it's a financial investment. The funds, the effort, the time, all three have to be optimized. So that is why they have got a metal framework. So when you have a metal framework, you can develop some of the things which is going to be reality. The same metal framework have come out with in situ construction techniques. The feasibility of converting lunar soil to a high performance fibers, and that can be used online for the construction of the lunar base. No need to take any material from here. It is quite expensive. If you want to take a ton of material, it costs billions of dollars. So you have to take a minimum equipment and maximum construction. How is it possible unless you have some studies done on Earth? That is why people want to go for additive manufacturing. It's called additive manufacturing. Part of additive manufacturing, you have 3D printers, you have many other things that are coming up in the future slides. This is the another way of looking at in situ construction technique. This is the aim of keeping a human for long time survival. What is your long time? Minimum 60 years. In the metal framework they have defined the long time is minimum 60 years. If that is the case, the lunar regolith and the mineral composition, even though it is similar to the Earth, but growing crops point of view, storing water point of view, and supporting the human life in the extreme radiation point of view, it has to be supported. That is why the lunar regolith powder is being brought to Earth in view of the journeys to Moon. The entire research will be done on that, and you do a 3D printing, you do piece of materials there on Earth, and actually practice same thing in the lunar surface. This is the total way of the additive manufacturing. There is a selective laser melting and laser metal deposition. These two things are specialized for life supporting matters. The construction is going to be done on the surface, and lunar base requires a fuel. I said the fuel tank is taken to the gateway. In case the module which has taken the human is actually after landing, the fuel leaks out. There should be a way to again refuel it on lunar surface. What do you use? If I am able to decompose, or if you are able to split the water into hydrogen and oxygen, that is the answer. You have a hydrogen, you have an oxygen. And later, if you are able to make methane after taking some of the plants there and carry out some growth, and that is also possible. So these are the technologies that are being looked in additive manufacturing. When this is going on, scientists have declared it is already time to declare that lunar anthropocene. What does it mean? That means humans are going to pollute moon already. They don't want to say the moon is anymore a celestial body untouched by humans. In fact, billions and billions of years ago, Earth was also like that. So that is the moment the human colony or the human race starts entering on the lunar surface. When do you declare the starting point as Anthropocene? The scientists call it as already started. Because 100 spacecraft have already touched the moon, whether landed or crashed. And few humans have landed. That is what else you need to call that as Anthropocene? You already started. So let us call it and start monitoring like our pollution monitoring being done on Earth. What these people will do, what will happen to the lunar surface. You are going to leave a mark, permanent mark there. This is what actually, I want to say one more thing. I said a few years somebody has stayed in the, astronauts have stayed in the ISS. Can somebody tell here, in the Apollo, how many hours an astronaut has spent? 70 hours. He has spent in a capsule 70 hours. Out of that, 22 hours he has moved on a rover. 22 hours he has moved on a rover. What example you need to say that at least few hours a human have been subjected there, subjected to the atmosphere with all protective clothing, protective. That means it is possible to have a kind of a living with a couple of people initially for a few days. This is what somebody wants to go there. What you are supposed to take in the lunar suit? You have an oxygen supply, food, medical, power source, communication, transportation. That's it. And how does the suit look like is given here, and that is self-explanatory. All of you can look at it. And this is the technology. People want to complete it, make it a reality for spacecraft platform, there are Moon or Mars or whatever it is. This particular technology is the light opportunities, next generation avionics, lunar surface innovation, the sustainable living, in situ resource utilization, survival and habitation. And later on, taking moon surface is one of the ways to travel to Mars. Human doesn't want to stop there. He wants to take one half travel. Imagine one half travel to the Mars. In such cases, the technology, what is the type of technology people started working on it now? This is the characterization of the soil. The project site characterization. What will you build? Where will you build? And what type of operations you do, whether you use robots or humans. And this is called, in actually, that you call it as concrete. And the lunar surface, it is lunarcrete. The moment you make a lunarcrete, you get a compressive strength of, you need a compressive strength of 39 to 75 Newton millimeter square. It has got an Young's modulus of 21.4 kilonewtons per millimeter square. It has got a density with compressive density of 2.6 grams per centimeter cube, and it has got a temperature coefficient 5.4 into 10 to the power of minus per Kelvin. So these are the things already modeled, made available. In India, if somebody wants to make a startup, there is no need to make this analysis. This is available and this is being practiced. If that is the case, you can take this as an information, start moving. That is the idea of showing this slide and how do you characterize the site for landing or living. There is another reason, it is full of craters. You must have read in Chandrayaan 3 landing how much time it took actually to identify a flat surface for landing. So those are things. Anyway, this is the total program for 2030. they want to take at least a few astronauts there. And whatever I have got discussed now, they are all listed here. You need a launch, you need a navigation, you need a lighting system, you have communication, you have protection, you need refueling, you need power, you need electrical cabling system, you need construction, many other. These are the things when you want to make the infrastructure and lunar surface. And the moment you want, I said, there will be a lot of dust. Dust will not settle. Then site operational condition. How do you produce light? If you have 14-day night time. And how do you support, how do you live with the temperature? You have 14-day night. You need a vehicle, you need a communication, you need a lander, and you need power farm and many others. So these are the conditions which I listed. And the total construction classification is divided into 3 parts. Pre-integrated, that can be taken from ground, that is earth. That is class 2, that can be taken, you can use the local material there, make a machinery and construct. There is a class 3, in situ manufacture. These are 3 varieties. And what are these 3 varieties? Anyway, this is the introduction to you, especially all the students. You can have a look at it. If required, my presentation will be with you. And these are the 3 classes of varieties: pre-integrated and prefabricated and in situ manufacture. When you do that, this is the innovation initiatives started working on here. You create a surface which will have 1/6 of the gravity. How will you create? When you have any time felt a kind of a gravity difference when you are moving on a giant wheel? How many of you? When you go to the top of the giant wheel, yeah, sometimes in aircraft when they are taking off. So how do you create that surface? And let us say if I through a balloon, if I float an instrument, what is the G on the instrument? It is still 1 G, but it is floating. It is possible to create a near 0 G by making vacuum and putting some opposite forces that nullify the gravity. There are laboratories, and in fact, when I went to recently in Hyderabad, somebody asked me whether we can have a